Paul Coggin.
Shut off.
So this presentation basically was inspired out of my frustration of hearing all the critical infrastructure organizations getting popped, and the default answer always being APT. Didn't matter what the problem was, it's APT, because APT, you can blame the PLA and you keep your job. Because who can fight a nation state? You know, especially when there's hundreds of millions of them, right? And secondary to that was my frustration with all the cyber legislation, with the volunteer phrases in the language, like these organizations are going to voluntarily actually spend money and fix things. They haven't fixed things with the compliance. So basically what it's going to be is I'm going to get into a lot of war stories and some recommended mitigations. We'll get some real world examples of what's going down as we go out and do consulting. So my background, I'm a telco service provider, critical infrastructure guy. I focus on the networks, either design, implement, or secure, or figure out how to break into these networks that are unbreakable, according to all the marketing and what they were telling Congress. You know, there's all this separation of services. I'm going to show you there's no separation. It's end to end. So basically the problems that we see, no matter where we go, whether we go in to do the pen test or somebody got there before us, and we're coming in to react. It's prolific layer 2, lack of segmentation. If you can get any kind of access, you can move horizontal and vertical at will. And the big problem is trust relationships. There is no security in the integration and interdependencies between all the different systems and the vendors that have been put in. If they have a database, the database is easy to knock down. Nobody has secured the databases. They might have looked at the web app, but the client-server relationship with the databases, that's always low-hanging fruit. But like I said, if it gets popped, it's APT. It doesn't matter if it's problems that's existed for 20 years, like ARP poison. You know, how long has Ethernet been around? Since the 80s, and you can pop any of these networks with it. So here's the networks that I'm typically involved with, either designing or trying to figure out how to secure or break into. The industry calls this a next generation network, where they're trying to offer triple play or quad play, voice video being cable TV over IP, internet services. I just read where even Comcast is getting into the power business. They bought a municipal utility, so now Comcast up in Philadelphia is in the power business. It's all converging together. I haven't been involved with any of that. What I have been involved with is the telcos getting into providing smart grid services, which SCADA, et cetera, runs them. So basically what you have is at the top, we have the operational support systems or business support systems, where the brains of the operation is, where you have the automated provisioning. You have the CLIA, Patriot Act, lawful intercept type infrastructure, depending on what type of organization you are, how large you are, that you're going to have so that the feds can come in and do a wiretap on demand. And with all the middleware to tie into the billing system, maybe middleware to tie in with the smart grid systems between your SCADA, etc. Up at the top. And as you flow down into the network, you're going to get into the infrastructure where it might be a DWDM transport infrastructure, where you're multiplexing wavelengths, different colors of light across fiber, so you can get multiple connections over a single fiber. Or it could be MPLS over glass, like MPLS over the DWDM network, which is replacing the old legacy ATM and frame relay networks. You could have some SONET, some SONET out there. And you get down into whatever the organization is doing for edge aggregation, like passive optical. Some of them are actually rolling out active Ethernet all the way to the home. Even the utilities are rolling out Ethernet all the way to the home. And what we're seeing is that the utilities are getting into the telco business because they're rolling out smart grid. And if they don't go and roll out an RF network, they roll out fiber wherever they have a meter. You got fiber, why not go and offer voice, video, internet, and cellular backhaul and any other service, because you've got the pipes. And so in many cases, the utilities will go over ahead and roll out a active Ethernet, basically a full Ethernet network, all the way to where the meter is. But the big problem with this is what I'm saying, and out of giving this presentation, and come to me, the big underlying problem with this is the vendors. So I come up with coined the term vendor persistent threat. And instead of day 0, day V, the day the vendor shows up. What happens is in all cases, all of these different systems is a different vendor, and they're writing into their contracts. I've got it on my desk. I've got contracts where the organizations have given it to me, where there's language in there. We will have remote access. We will put our systems in, and we will be coming in remotely to support you. And they need that because if you go into small town America and you drop a network with this complexity and the majority of the infrastructure's never existed, and they went and got bonds, they went and got capital somehow to go build out this new next generation network. You drop all this tech in, somebody's got to run it. Well, all the vendors are going to keep it running to keep the customer sat up, keep the business running, get the money coming in. It's all about the money. But the problem is, as you guys know, especially you, I know you're a pen tester. All you got to do is figure out what vendors are in this network. Go out and look on LinkedIn, find out who the techs are that are rolling this stuff out because they're going to brag about it. Pop them, and then wherever these guys are, you're able to get into the network.
What's the authentication mechanism typically used for remote access into?
I'm going to give you some real world examples here. You're going to love this. And then the other side is you just got to go in and social engineer the techs that work for the company, and then you can go in and pivot and move horizontally and vertically all through this network, through the infrastructure, and take out services. And so I'm going to give you some real-world examples of what's happening there. Now, this is the ANSI ISA 99 architecture for SCADA. This is how the international standards bodies recommend you architect a network for ICS or SCADA systems if you're a chemical plant. If you're a chemical plant, it's some kind of manufacturing, they call it industrial control system. ICS, you talk to utility, they call it SCADA. But this is different layers where you go to enterprise and you work your way down into the SCADA DMZ and the SCADA, other SCADA systems down into the control network. And you see that you have firewalls here. This is a really nice architecture, and if it's implemented and configured correctly, this is awesome. I'm still looking to see one of these implemented. The problem what we see in real world is where you see the firewalls, in some cases, they're literally an NT 4.0 box or XP box that's multi-home with 2 legs in it, one leg up to the business network, one leg down into the SCADA network. A firewall may be put in place. Typically, the firewall goes in after somebody's come in and did a pen test and hacked the network up and has recommended a firewall. When you come back in to do the second or third pen test, the audit, when you get invited back in again, what you find is the firewalls have got so many holes in them that the firewall is basically now just a router just to pass IP traffic between segments. They had a firewall so you can check the box for insurance because they're not under compliance because it's voluntary. At least with the small guys. I mean, this is what I'm talking about. I'm talking about the small guy. I'm not talking about your TVAs, your southern companies, the guys that generate power. When I talk about the utilities here. But basically, what reality is, these firewalls are nothing more than routers. When you go and look at their ACLs, if they have the firewall there, and then you have the vendors who want the remote access in, because they're going to have the remote access, and we don't see the dial-up as much anymore, but they have all the VPN capabilities so that they can come right in and easily access these networks. And what's really bad, you talked about passwords. Saw a SCADA system the other day, 3-character password. The marketing literature says that the system is secure because it's on an old, obscure operating system that people used, basically before you and I were born. And so it's secure because
secure by antiquity.
Yeah, three character.
Never heard that. Security by obsolescence.
Yeah. Three character password. Can't make it up. But all the marketing literature on the company all says it's all secure. It's just old arcane OS that nobody uses anymore.
Like to support it.
Right. So here's a first war story, real world example. Went into this utility somewhere in America. Worked troubleshooting a Metro Ethernet problem for them. Social engineer started talking to them about getting them to show me their network so I could see how things work. I got into the firewall to further troubleshoot the network, and there's 2 vendors involved. And in this case, on the left-hand side, the billing system vendor. There's a common thread through this presentation that I've come. These billing system vendors. they're the high priest of the vendor persistent threat. I mean, these guys are the ones that are really doing the most damage that I see. They put a firewall in for the organization. ACLs, the firewall filters, the rule set, kid you not, permit any both in and out. And then, I'm trying to pick myself up off the floor.
Well, there's your router.
I mean, permit any both, but they host it in the cloud. The billing system's hosted in the cloud, so it's secure, right? And so then I had to ask the guys, trying to keep a straight face, like, show me how you get into your SCADA system. Show me that. And the guys go and show me. It's like, oh yeah, we'll show you that. And I expected him to go and start KVM in or walk me down the hall. He whips out his Android phone, and faster than my eyes can keep up with, he has his SCADA system in my face on his Android phone, and no password on the phone, no VPN password, no password to the server, straight in, fast as he could hit VNC on his phone. And I started trying to go and offer the gentleman free security consulting because I feel bad for how the other two vendors, because the second vendor did the VPN to him. I tried to offer him free consulting. I was like, you've been taken advantage of. I want to help you. Joker got mad at me for wanting to help him and tell him that this network was unsecure. We started going through, but he's like, the guys that work for him, they love it because they can go hunting. I'm a big hunter myself. And he's like, the guys can be hunting and they can monitor the system, without having to be at the office. And if there's any problems, they can go and address it and call in help, etc. It's all about ease of use. But this gets back to this whole voluntary. All the focus, you see all the legislation on the TV, on the news, with NERC and FERC, all that's all focused at TVA and the Southern Company type level where the power generators are. Nobody's dealing with these small guys. But it's the small guys we're pulling power from. And if you have an advanced adversary come after us, they might not get the top tier. All they got to do is get the spokes. And if it's this easy,
Get the 4-block radius.
right? They get a database of all the small guys, build up a database, and they just go knock all the small guys. And I've seen this around the world. I was in Malaysia, same story.
Or if it's 12 degrees and you really need to lower your utility bill.
So get into some of the telco stuff. The telcos are moving towards providing all this smart grid services to the utilities in many cases where the utility doesn't want to go build out their own network. So the focus I have is on, like I mentioned, is on the network. And I specifically go after the network management system because my thought is if you can take over the network infrastructure, it doesn't matter what the other vulnerabilities are. If you get the network infrastructure, you own everything. And so we'll go after. I focus on trying to find the network management, and what I've discovered with network management is it is always if you can find your way in. If you can find your way in to say exploiting the trust relationships for remote access into this OSS provisioning, where the business system networks are, there's trust relationships over into the network management network where there's databases and God knows how many web apps and out of date, out of patched servers. Typically, some old Solaris boxes run with that have not been updated. And if you can find your way in this, you can go and pivot your way in and pop on and take over the whole core network infrastructure for tens of thousands of users. Pretty easy. That's how the architecture works. So here's a real-world example. We're seeing in a number of places where the vendors for the soft switch is a class 5 switch, phone switch, basically like voice over IP. If you were an enterprise business, you might use a Cisco Call Manager or a voice over IP system from like a Avaya. But if you're a city, if you're a telco service provider, you're going to, or a cable company, utility, et cetera, that's getting into providing services, dial tone to home subscribers, you're going to use a soft switch where you can support tens of thousands, hundreds of thousands of users possibly. Well, what we're seeing is the vendors, they put in a network management system, and they require this in their contract language to be able to have this access. And the systems they're putting in are dual home the Linux boxes, but it's secure. Getting back to your question, it's secure because they're using SSH. But they leave out the fact that they leave at a surface of attack that anyone that can find that SSH service can connect to it. and for some reason they're not locking out attempts and locking out the account and sending alarms because all you just have to, because what we're finding is both in the case of SSH and the transport networks. The transport networks being the DWDM, the SONET, the core routing that's providing the backbone for, say, smart grid, SCADA, and all the telco services. Both vendors are putting in these multi-home systems, and all you gotta do is find that SSH daemon and just do a brute force until you finally get in. Old school.
What if you
How
just
many of
automate
these
that?
change the SSH port to make it a little more difficult?
No, they don't do that.
They never secure the certificate.
They don't do that. And in one example here, the company had a $500,000 investment in security infrastructure, and the vendor who put the transport network in, politics. It's all about politics going up to the top. The transport vendor was able to bypass all of that security infrastructure. They wrote the big check, did all the right things, poor implementation because there wasn't policy at the top of how things would be implemented consistently, and even bypassed it. But what we're seeing is these guys are getting popped left. It's getting popped. I was actually on stage on a panel with one of the soft switch vendors and with an executive. And after I got through talking one time, he pulled me off to the side. He's like, "These systems are under constant attack." And I'm like, "Why are they under attack? Why could you see them? They shouldn't be seen and exposed, but they are." And it's because the vendors want to be able to remotely manage them. The techs need to be able to remotely manage them. And now there's all these new services that the end user subscribers want to be able to self-provisioning. You'll see in the market literature all this self-provisioning. There's a path, a trust relationship path into this infrastructure, and if all you got to do is get some kind of handhold, you can just start pivoting in, and they are. And so another big problem we're seeing with the critical infrastructure is this is what's happening here is the telcos will go in and sell a ring, and if you come up through regular school, if you don't go and work in a telco, you think a ring is a ring. You think it's a geographic dispersed ring, like from Atlanta to Birmingham, maybe over to Jackson, Mississippi, back up to Memphis, back over to Nashville. Big geographic ring. No. What we're seeing actually being implemented in many cases. If you ever wonder why a backhoe picks its teeth with somebody's fiber and knocks out services, what's happened is they got the ring is the fiber is just a bundle of fiber in one sheath, and they electronically and logically ring it on both ends so that it's a ring, so it meets FCC regulations for a ring, but there's not a physical fiber ring. So what you have is we have one real world example has some entrepreneurial bubbas somewhere in America decided they was going to get into the copper business, started climbing the telco's poles to steal the copper off the poles, instead of getting copper, they got fiber, and knocked out services between cities. You started creating islands of communications where they can't get out.
Well,
That's a lot of money.
Right. This stuff right here, though, this doesn't come up in all this compliance legislation, that, volunteer stuff that's coming out. You won't see those. So here's another example of a problem. Had a telco bring us in to do a billing system, to assess the whole network from the internet in. And the billing system vendor put in a firewall for them, and of course put in a billing system, and you would expect best practices there would be a DMZ split off for an external web server for a presence for customers to interact with their system. In reality, what we found is in this particular case, the vendor put both the external web server and all the internal assets on one system behind the firewall that they put in. So that all you had to do is find one vulnerability on the web server, and you own everything. And we were able to, in this case, find some directory traversal and ended up getting a JBoss shell on the system. And by way of getting that shell, we're able to go and gain root access into that system. We were asked to stop, but we could have easily, because of this billing system is integrated with all the provisioning networks I mentioned for end-to-end provisioning, so that a customer service rep, the lady taking phone calls, provisioning services on demand, where they can just click a couple buttons and services get automatically rolled out to the end of the network. I hope we were going after that because we were going to follow that chain of trust and take over the whole network infrastructure. Got to ask to stop. One of the things I learned as a techie out of this is you really got to be, it all comes down to the financial conversation. Because we did the out brief, had a stack of report, stack of screenshots of how this went down in detail. We got told we were wrong, billing system's right. The billing system vendor's right. The billing system vendor is now in the security assessment business. We no longer do security assessments for these guys. And long story short, I started learned that it's not good enough to be a tech. You got to have a business conversation. The guy who was helping them get their bills paid, billing customers and getting revenue coming in, they win the conversation. Not about the technical details. But again, you know, all the cyber critical infrastructure conversation happening in Congress. If it's voluntary, nothing's going to happen. These billing system vendors, whatever vendor, they're going to get to do what they want to do with these organizations on the spokes, because they're not publicly traded. They're not a power generator.
One slide. I just got a question because I don't know. Does the billing system pull its data from the ICS?
Well, what could happen with a billing system, from an ICS standpoint, smart grid?
Well, I'm saying pre-smart grid. Right now, old manual meters. It's still that's walk around, right?
Well, you have these systems called historians. You have these systems called you have a historian here that's pulling data immediately from the SCADA system.
Okay.
And then this data should be replicated to a separate database. There should be a lockdown conduit, a connection that's very secure, where this data from here is being replicated up to this system, which is then locked down further. Again, here, and replicated up to, say,
all right, no,
billing
that's what I was
system.
looking for. Okay, yeah.
But that doesn't exist.
No, it's fine. I just want to get the architecture, the theoretical architecture.
This, you know.
Shoulda, coulda, woulda.
Yeah, right.
Okay.
But these billing provisions, they're like contracts in law. I know it's the same here. And you can basically produce a contract for millions of dollars of telco service for the value of 1 cent. Meaning you pay 1 cent for $1 million of service. And it would be legally binding. I don't know if it's the same here.
Only if you use Bitcoin.
In the UK, it is legally binding.
So,
Same?
I mean, manipulating costs and prices on websites, the shipping the product, and it's legally binding.
to get to we get back to your question about SCADA, what keeps me up at night with because the world's going smart grid crazy. And it's all about green. It's about getting rid of the truck roll, being able from the internet all the way down to the smart meter, end-to-end provisioning, just like what the telcos have. If you want more bandwidth for the weekend, because your kid's done good on his grades, and you want to give him more bandwidth so he can be faster on the internet to beat his friends in whatever games he's into. That same logical trust relationship from the internet down to the broadband modem is going to be down to the smart meter for the utility, all the way down through, and there's not a separation. It's pure propaganda. There's a few utilities that do have that total isolation. They're very, very small. There's nuclear plants. It's documented. I'm working on a class on this. Documented. Southern Company had a nuclear plant that had that connection from the internet all the way in. Some of these connections are not very well documented, but they have that chain of trust all the way in. So what's happening with smart grid now is you'll be able to go in, pay your bill, and SCADA and everything keeps working. You don't pay your bill, there's a notification sent to SCADA from the billing system down to your smart meter to be able to kill your power. No truck roll. You go pay your bill online, there's a communication from the billing system to the SCADA on down the smart meter, turn your power back on. Never was there a truck roll like in the old days. That's where we're going. It's a great concept if it's implemented securely.
Yeah, well, it's not.
But where is the systems engineering requirements?
Well, there's, I mean, Zigbee and open TCP/IP.
So here's an example of the core transport network. Had a telco. They implemented some transport gear to build out a new 10 gig core network. In the vendor, what they did for the transport network is they're getting into cable TV, and with cable TV, all the TV channels are multicast. They're IP multicast. Your TV channel is mapped to an IP multicast address. So when you're hitting your clicker, you're changing an IP multicast address. And they want it to be instantaneous to have a high customer sat, so that it works really, really fast, and that you lock the service. And so what they did to help that, they broke the RFCs with all the latency in the protocol natively, and implemented it into ASIC, so that anything that got put into the VLAN that was dedicated to cable TV, it would automatically get replicated out. And then they had different VLANs for voice, different VLANs for data. It works really, really good. Until what happened in this case, a technician accidentally provisioned internet traffic that was Lord knows how many users off of a segment of the network. Put that segment of the network into the cable TV network, where traffic, anything got put in that VLAN, got automatically replicated out. So there's all this denial of service traffic from the internet segment got dropped into this cable TV network and starts getting replicated out, not only natively by the IP and the end users, but also into the hardware of the literal transport infrastructure. So the whole telco segments of the telco network just rolls over due to this security problem.
Wow.
And the only reason they were able to find this is they had some tools in place to give them visualization on what was happening to troubleshoot this. It was a crazy problem. But again, if something like this happened mischievously on purpose, is there any requirements to go in and have that capability to be able to troubleshoot? Because when we're talking about knocking out the network, we're talking about 911. It's not just some inconvenience of cable TV and internet. It's 911, no emergency calls. So here's another problem we're seeing.
They could have knocked their own control network out.
Yeah, and then on those same networks, you got the whole smart grid and SCADA running across it, all those services. So in this case, with this story, someone sitting somewhere interesting in the world was looking for modems, and they found they knew about some backdoor passwords in some routers, in the broadband routers. And a couple of telcos, in this case, they had not implemented a separation of service, secured their control plane, their protocols, the management plane, how the devices get managed from the data from the regular internet traffic. And this individual was able to go and get management access to their modems.
CPE.
What's that?
CPE.
The customer premise equipment.
Okay.
Basically your broadband router. Whether it's cable, DSL, whatever. In this case, it's DSL router. He was able to go in and this individual was able to go in and get access to, and for one telco, they had the security monitoring capabilities put in. They were able to catch it after 600 routers got popped. Another one didn't have it. 6,000 routers later, they finally caught it. And basically what the individual was doing was reconfiguring the router so that when it handed out DHCP IP addresses on the local home network, it would hand out a bad DNS and redirect them to a data center somewhere else so that they could go do a man-in-the-middle attack against any kind of online banking, because they were going after specifically trying to do a man-in-the-middle against banks.
That's cool.
Yeah, that's pretty cool. So we saw this first. We saw this problem first, and now here later, the same thing happened in Brazil. And in Brazil, it hit 4 million routers before they stopped it. It was over 4 million routers got popped. But this was really simple, because all they had to do was lock down the management plane of the network. If you're not in a trusted network, you should never even been able to see that interface to be able to make that connection.
So just to make sure I'm tracking on this,
if you're in a high wealth community, in that case, to do the man in the middle attack, they just had to be on the management network, and then all those high wealth people that are using the DSL or the cable modems, you can deal with their internet traffic to do your man in the middle versus.
What they did not secure the router so that to access the management interface on the router, you had to be in a secure network. They had it left open so that anyone that could find that router could log into it if they knew the password. This gentleman knew a backdoor feature. They didn't pay extra. It's that whole vendor persistent threat thing. That whole Dave V. You got it with the box when it showed up.
So if they would have put the fourth letter in the password, then it would
made all the difference.
Yes.
Well, they wouldn't even known it was there, but they should have had the network locked down so that the IP address should never have been even found. The services and access should have never been permitted, so that even though there was a backdoor there, the backdoor would have never been discovered. It's all about doing those layers and doing basic systems engineering. Basic systems engineering is where it's all falling apart. In the initial requirements.
Well, I mean, your diagram said, and you said, this is awesome if they did it right. So is it the systems engineering fault, or is it OPSEC here?
Implementation.
I mean, if the design is right, somebody's still got to make it work.
But see, that comes with the design.
I'm sorry, go ahead.
For it to be in the design, there's got to be a requirement. The requirement is surf the web. That's the requirement. And the requirement is to get the customers to pay to write checks. That's the requirement. Turn up new services for internet. There's not requirements being put in at the very front where, say, if you're dealing with a utility or telco, it's where they're going to get government funding, in like RUS funding, or what we call rural universal services funding. Like you see the bills on that extra line on your phone, utility bills. Well, that money is funding these networks to get built, and they bring in licensed PE firms, professional engineering firms, to design these networks. The PEs are not writing in the requirements for whoever's going to bid these networks that they're going to implement these networks securely.
Is there no requirement to implement the NIST 800 series?
No, not down with these small guys. If you're not a publicly traded company, or if you're a utility, if you're not generating power, or you're large enough that you're pulling like a 500 kV feed or something like that, it's a really large feed for a spoke municipal. They do not fall under NERC, so they don't have any of those requirements. It's voluntary.
Well, let me ask you a question. Hold on one second. In England or Sweden, is that true? Same conditions?
I was the security architect for BT's first 21C models. So I had that transcript.
Very much what you're talking about is the same in Sweden about small companies. And the rules and regulation are the way you are saying. They don't have to follow any standard. That is,
Even though they're tying into the rest of it.
So we had Ionica go bankrupt, and we had to pick up the tab and recover them.
I was at a SCADA conference in Malaysia, and I was just amazed at what I heard there. The same stuff. It's prolific everywhere. Vendors are consistent.
One of the other problems is EMC have had so much money, they've hoovered up, and I had a product called Voids Compliance. And the theory goes, if you don't own every port on your network, someone else does.
Yeah.
And I did own every port on my network.
Right. And so like this hack here, this happened to some people we know, and then a period after that, it hit 4 million routers in Brazil. They're not locking down this. They should have just locked that down. But to get to your point, yeah, I mean, they reconfigured the router so that it didn't matter who you were. You go surf the web, you're using somebody else's DNS, and so for specific banks, they would have the DNS set up to go to the bad sites so that they could do an attack against your.
So, but the design engineers, obviously, I mean, they know about this, but they're not writing it in to the design because the vendors aren't stipulating it as being a requirement.
Well, you got multiple problems. You got the engineering firms who are laying out the requirements for the RFPs to be bid against, and then you have the implementation engineers.
Cheapest is best.
I've got more certifications than I can count, and I tell you, they do not dig into this. They tell you how to turn knobs and how to turn on security features, but they don't lay out the threats. So if you go take a class and you become certified router guy or certified firewall guy, you don't understand the threat of how and why you need to implement these
You only know
capabilities.
your bit, the switches. The switch guy and the router guy typically.
The minute somebody starts writing that in to the work order, that kicks up their cost.
Speak up so everybody.
Right, and you got a good point. And then the concern is it's going to run its cost. But you know, whenever I touch a network, I got a template, copy paste.
Yeah.
It takes me the time to copy paste. I do a search replace to the IP address and copy paste because I got the policy. But based on what I know of the threat and what I've seen, I just keep adding it to a template and it's copy paste. It's not that hard. It's just it's
So
not a
little things
requirement.
like having an internal BGP,
Right.
not communicating externally from your BGP
Yeah. Well, let's get into
unless you have to.
well, this one we get into a new problem. I've only seen this one time, but it gets back to that whole separation of the services, securing the protocols and management. This telco, they needed some bandwidth. They had an emergency. They needed some bandwidth and they needed it fast. And they didn't have the new network infrastructure in place, so they pulled an old mothballed router out to terminate a ATM connection temporarily to bring up new services to run BGP to an upstream provider. And I've never seen this but one time, but a customer started doing a BGP attack against this new router and rolled that router over, which because of the way they had the BGP set up, ended up knocking out a great deal of their services. But the point being is BGP is something that you run to your upstream provider, like with AT&T, Quest, Sprint,
Yeah, but they could
Global Crossing.
the next one up the stream. They could have killed you internally by doing that.
Right. But there was no reason. There's no reason. It gets back to that whole trust relationship. There's no reason that someone at the spoke down at a home
Never
would be running a BGP protocol
Never.
that the global internet runs off of, should be running that in with you trying to establish a session to your internal network. So it gets back to those requirements, those basic systems engineering requirements, that if it's not needed and it's not permitted, should be permitted, it's never going to happen. It should never been permitted for those type of protocols to initiate a connection with the router.
Was this Cisco equipment?
I'd prefer not to.
Well, I mean, if it were Cisco equipment,
There's
you
only
would
a
have
handful
expected
of
enough of a
products.
relationship
Legacy.
for them to give the basic.
What's zip code?
Oh, shite.
Yeah. But I thought this was interesting. This one, utility. Here's they're getting into, like I said, they're getting into rolling out smart grid. If they're not doing the wireless, they're running fiber out to the meter in many cases, and so they're getting into the cable TV business, voice, internet, data. The main reason they're getting into is fear of deregulation, so that anybody can get in the power business. Because right now, in years past, they had a monopoly. They lose that monopoly, they got to start operating like a real commercial business with competition. So they got to get into new services. And so now the cable company is a telco, the telco is a cable company, it's all. So what's happening is they put in these networks, and you got a billing system, you got middleware, you got the SCADA system, all the smart grid management operations, you got video on demand systems, you got all the internet. They put all of this into these networks. And typically they're just big flat networks where everybody trusts everybody. It's just all about getting blinky lights
What's a
working.
PV LAN?
It's a Cisco
Private?
protocol.
Private, it is private VLAN.
Okay.
But they don't do that. There's no concept of that. It's just one big flat network. And what happens is a lot of these vendors, again, because they got to keep this stuff running to keep the customer side up. Because you don't want, because Bubba Pole Climber, who got nominated to be the data center technician, got pulled off a truck and got put in a data center. He doesn't know how to run all this high tech. So these vendors have to have a connection in to keep things working, to keep the blinky lights happening and the remote internet happening. So what happened in this case, a vendor got popped at their headquarters site. The hacker pivoted off them, came back in, exported the trust relationship, came back into the utility,
Owned everything.
and and then all of a sudden somebody shows up at the utility with a new server, rips out the existing server, puts in a new server. It's like, look, squirrels. Which
In all the stuff that you've done, again, the focus here has been, ICS, SCADA. When you go in, other than the company that fired you because of the billing service,
right.
are you able to go in and do they allow you to fix it?
Big job, really.
Like us don't fix things.
Well, fix, improve, improve.
We give them a report with a plan of action for mitigation.
Yeah.
Sometimes we're permitted to do that. Now, what you get into in the business is the guy who told you there's the problems. You don't want a conflict of interest, so they give the mitigation work to someone else. So if I do the pen testing, you might get the mitigation work.
But then are they going to bring you back to certify
To
that
audit
the
it,
mitigation
yeah.
was done correctly?
Very rarely does that happen.
Because they don't have an ETO requirement.
That's right. There's no requirements.
They're
It's
not
all,
required to actually be
What do
secure.
you know? What's
no, there's no requirement.
What's
It's
astounding,
voluntary.
astounding to me is fundamentally you get your data networks, corporate networks, tying to all of this shit, but the corporate networks do have at least HIPAA and a couple of other compliance things going on, and I guess common sense is if I'm touching that, doesn't that extend the compliance requirement? That's what some of the original compliance documents said.
In theory.
Well, a lot of these organizations, you got to understand, the reason they're doing a pen test to begin with is for insurance. So that's the reason they bring an organization in to do a pen test. We discover some of these problems from an incident handling because they get a letter from a lawyer, say from Europe, says cease and desist attacking my bank, and then we get brought in and we find these things. But if they bring us in as a pen test team, it's purely for insurance. It's nothing to do with compliance. That's what's frustrating me with all the conversation we have going on in D.C. with all this cyber legislation. If you listen closely, every now and then they'll slip in voluntary.
So what happens if it's hostile intelligence services doing this? Does that allow your secret service to get involved in forcing to do it?
I have no comment, no opinion.
There was one of the presenters yesterday, and I forget who the person it was, but they had some numbers, and it was showing like between 25 and 28% of the botnets were systems in the U.S., and this is the type of thing that makes it easy for them to continue to.
What was that website of yours with?
What, bad ideas?
This
Or mine?
is too scary for me.
Yeah.
I fought this fight before, and that was nearly 10 years ago. This is too scary.
So here's one of my fears is that say that scenario I just gave you, a vendor gets popped, the bad guy pivots off of the vendor who's got a large customer base. They get into a network like this, and then they come in after exploiting, say, a customer exposed. They pivot back and start hitting other suppliers because all these different suppliers are going to have their own VPN trust relationships back to their headquarters sites. And so if you're a hacker that has, like we talked, there's no rules of engagement. Your rules of engagement make the Geneva Conventions.
Going back one,
If you follow those.
your most frightening internet one, which might just be enough, you had an internal BGP relationship with a tier 3 provider, probably going up to a tier 2 or a tier 1
Yeah.
provider. If you turned off the ability and requested them to block all their BGP for everyone, that would impact.
I don't know about the other parts of the world except for what I read on the internet, but in the U.S., the upstream providers, they're very good about locking down their BGP. They
I bet
protect.
they are.
They don't trust those spokes. They lock their stuff down, and they have very good engineering. I mean,
Because that's how they turned off the in Egypt. They just blocked an internal BGP. One little command.
but now you get into other parts of the world, BGP and things get more wild west. But they could easily, even though these systems are implemented badly, they can easily go back in and fix them, like by doing things like the private VLAN and putting in VLAN ACS. They've already bought the equipment. equipment and features are there. And that's one of my problems with the whole industry, the security industry. And my company, we sell equipment, but we'll sell you Cisco whatever you want. But a lot of these organizations already bought equipment. They bought firewalls. They bought the routers and switches.
Person, don't they?
They just haven't been implemented properly.
If you were to fix it, you've said your company sell boxes. Wouldn't you support the one guy in there that could be the key man that goes around and owns the problem for the bosses? Isn't that what required? A named owner? Does that not exist as a concept? This is my patch. I own the security policy. You muck around on my network, you've got me to deal with. Just like the old security officers in our world.
Wait, what's he going to do though? What's
Oh,
the hammer that he's got?
No, it's got to be at it's got to be at the C-suite.
Exactly.
The project what's got is got to be something at the C-suite compliance.
It's got to be a
Compliance
C-suite
with a hammer.
person. Yeah.
There's got to be compliance with a hammer at the C-suite, pushing down, which pushes down on the whole systems engineering life cycle, so that, these problems are getting
one of
worse.
the problems is also in the government. I don't know if it's true overseas, that the penalty is so minuscule. Hell, we'll pay the damn penalty. We don't care.
Yeah.
So,
It's cheaper than fixing it.
But the penalty
I
ultimately
think
is
a
you
lot
go
of
out
it is
of
hiring the
business.
wrong people too, like he was saying. You've got people that don't understand.
Oh, I don't
properly
disagree with that, but when you come into compliance, if I'm going to fine you, and you're a $10 million company, and I fine you $50,000 a day, fuck it, pay the
Have
money.
you ever seen any?
are you kidding?
I mean, that's the simple fix
No.
you've got to have first.
Yeah, that's not. That is a foreign concept. You got to have before they get into configuration management, they need a security policy. I mean, 3-character password. I'm almost. So I'm not I have more than just bad news. So, since I go and I look at the network infrastructure and the network management trying to break into these networks, most people just have to do all their network management in-band, and they spend all this money on top name brand equipment. They have the features to lock this down. There's a capability called MPLS and in a subset called bursts, where you can carve out not just VLANs, but at the routing level, at layer 3, in the routing table, you can implement bursts, and if you have a large enough network, you can actually implement MPLS and totally carve out the network routing table, so that the enterprise services or whatever the subscriber services are totally isolated logically in the hardware, and the management network, the brains of the operation, is totally isolated, and they run on the network like ships in the night. They're on the same same network, they're on the same router, but there's different routing tables. Unless you manually go in and configure that you want those networks to logically be able to connect to each other, though they're on the same hardware, they will never be able to touch. And when I go into pen test to try to figure out how to break into the network, I don't want to see nothing like this. I never have to worry about it when I'm in a pen test room. Nobody does this.
So for your nuclear company, 572 mandates that segregation. They don't have a choice, because the NRC will get on their backs.
You need to do some Googling. I've been, like I said, I've been doing some Googling, some research. You'd be amazed at the incidents. There was a plant over in Georgia. I forget the name of the plant, but there were connections going all over. There's an end-to-end path.
True, but they're mandated. They lose their license. End of.
I don't know. I don't know anything about it.
Bloody hell.
So, one of my thoughts is it's probably a rounding error for the amount of money being spent on these networks to go in and buy a couple extra boxes and have a totally dedicated out-of-band management network where the management infrastructure resides, so that if the bad guys start coming after the core infrastructure, there's no way for them to get in and have separate firewalls, separate VPN, and for the love of all things holy, use two-factor authentication, because the passwords are useless. You got to use some kind of two-factor. But if a dedicated network management infrastructure would totally lock things down. But I would be happy just to see this. But this would be really, really cool. So back to that whole basic persistent threat, no matter where we go, no matter what they're running, whether they're a Unix, Solaris, or Windows shop, they all have these problems. This goes back, some of the whole ARP poison goes back to when IP and Ethernet were created. I mean, this thing, geez, this has been, ARP poison, I mean, how long has that been around? 20 years? And if we get
Wasn't that
to...
after the IEC got approved?
It used to be a nice tool.
You ever found a system you couldn't ARP poison?
Right, yeah, and we still use that in EtherCap and, what's that again?
You ever found a system you couldn't ARP poison?
No.
Does anyone ever remove their default gateways when they don't need to for those methods?
No, they don't. Are you kidding? Yeah. And so one of my biggest suggestions I make to organizations is work the way up the OSI model. Start at layer 2 and let's work our way up and deal with, because if anybody gets physical access, whenever we do an internal assessment where we've got physical access, it takes more time to boot the laptop than it does to get to own the network, just with some of these simple problems. And if you just wanted to DOS them, you can fire up your Xenia and start attacking the different VLAN protocols. It's very, very simple. Getting back to our systems engineering conversation, there's a lot of conversation about doing host-based whitelisting with tools like Bit9. But that's going to get back into the conversation of you're overwhelming the technical staff because they got to go touch hundreds, maybe thousands of desktops. And then with the SCADA vendors in these.
Why do you have to do the whitelisting at the desktop? Like
You don't. That's what I'm getting to. But that's what people. That's the only conference you go to. All. I did 18 conferences last year, and all anybody ever talked about, they talked about whitelisting was at the desktop, except for when I got up to talk, and then I talked about the network. It's all the vendors. I mean, it's all about it's McAfee, Symantec,
But
Bit9.
they're pushing, right?
Yeah,
Or
there's not capability.
But your networks you can clean because they're not loads of ports.
But that's what my problem. That's what I'm getting to with this network. You've already bought the Juniper, the Cisco, the Brocade. You've already bought the equipment that you could without having to go buy something new.
I mean, they're RBAC. They're all RBAC. Do it there.
I mean, they've already got the core infrastructure in place. Why not go and lock down the network? But the reason they don't, the reason it's not happening is to do that at the network layer. Is you got to have the systems engineering to know what the trust relationships are. You either got to do the trust relationships down to the desktop of what applications you trust, or you got to do it at the network layer.
Do it the network layer and trust nothing else.
The network layer is a lot simpler because only a few ports.
But the
Yeah,
politics.
but you know what happens that I see in companies? Bob says, I have to have FTP. It's critical.
Well,
What do you
get a
need it
different
for?
VLAN.
For porn. You
Get a
know?
different VLAN. Get a
I think the
VLAN.
IT guys never want to follow by the same rules, and so because of
And
that,
the execs,
never done
Which is
on-
why
and the
you
C-level
don't get
guys, they want
online
exemptions.
VLANs.
Exactly.
exemptions to all
Sorry.
of this
And that's why it's been done
as
on the
policy.
desktop.
I know, but
With the network, why should end users be doing file sharing? That's why we got servers, right? Everything, all the traffic should be northbound. There should be no horizontal. So that somebody downloads the latest and hottest malware from the PLA,
Then we sit.
they get in. They should not be able to freely pivot horizontally. They should only have a northbound connection, and you should be able to put the focus on securing those northbound.
so you're seeing it
Flows.
even worse in the SCADA land than we see it in financial.
Oh, it's in all of them. It's in all of them. It doesn't matter anywhere, whether it's a bank, a school, hospital.
And these
How often, maybe percentage-wise, how often do you actually see PV lands and VACLs implemented on internal servers? Purely on the internal.
I'm going to see it the day after I see ARP poison block.
I did a paper 10 years ago showing how you can use PV lands to actually start mathematically
Right.
showing how well the
Right.
internal network is locked in from internal threats.
They all detect it, don't they? The modern switches all detect ARP poison.
Well, they'll do that, and there's all kinds of port security to go in and secure the networks against it, but nobody put those things in. And the reason they don't do this, the trust relationships, or put the flow zone is they're not going to lock down those trust relationships because politics. They're afraid that they're going to somebody is going to accidentally kill the service for somebody politically connected,
I've got.
and it's going to cause a bad meeting. So it's got to come down from the top. That's where I get back with this whole legislation being voluntary now. It's got to come down to some hard compliance with a heavy hammer, top down driven, so that everyone in the whole systems engineering life cycle is going to have skin in the game to fix this.
That's why servers are, that's why firewalls are not named Draco.
I've got a confession
Should
to
be.
make.
That's what I'm good
I was the OSS guys network bitch, and the OSS guys are the most important people.
So, well, this is my contact info. If you want the slides, you can reach out to me.
Your work is beautiful. I really appreciated that.
That's my
Because you live in hell, and you must meet some really suffering people.
And
Oh, dude,
if you're gonna do that, that's why you
Right,
you get jaded after a while.
Personal.
Oh, yeah.
But it's also
Well, that's the reason I created these slides, because I had to go bed and get it out of my system.
I've been there. It's like, ah.
This is my get it off my chest slides.
Um,
This is
Hooray!